In this video, I'll be going through the specimen paper from 2020 for the Cambridge International AS and A-Level Math Paper 1. I also have with me MF19, which is the list of formula and statistical tables. Okay, so this will be provided during the exam, so you can refer to this table for the list of formulas inside here. Okay, so now let's go on to question 1. So in question 1, you are given these points A, B, C, D, and E, and you are told that they lie on the curve y equals to fx. But you're not given the formula of fx. Okay. Next, the table below shows the gradient of the chords AE and BE. Okay. Complete the table to show the gradients of CE and DE. So basically, finding gradient between 2 points, it is basically y2 minus y1 over x2 minus x1. So for example, if you have a point x1, y1 and x2, y2, gradient is equals to y2 minus y1 over x2 minus x1. Okay, so now let's go through the solution for A. So to find the gradient of CE, I'll make use of points C and E. Okay, so y coordinates of E is 9, x coordinates of E is 2, then y coordinate of C is 7.75, x coordinates of C is 1.5. Okay, next type it into the calculator, you'll get the gradient of CE equals to 2.5. Okay, so here's 2.5. Next, let's find the gradient of DE. Okay, so again, I have point E, but now instead of having point C, I have point D. Okay, so basically to find gradient, I'll just use this formula here. So 9, 2, then 8.79 here, and then at the bottom 1.9. You're allowed to use the calculator, a scientific calculator. So I'll use the calculator to evaluate this, and I get a value of 2.1. Right? Moving on to part B, you're asked to state what the values in the table indicate about the value of f prime 2. Okay, so in other words, right, you're asked for the gradient at x equals to 2, or in other words, you're asked for the gradient at point E, right? So let's take a look at what we are trying to do in this part here. Okay, so let me erase this so that we have some space here so that I can explain it easily. So now, if you have to look at this, right, I do not know what is the curve, but I know this is my point A. So this is A, 0, 1. This is point B, 1, 6. This is point C here. Then this is point D. And this is point E, 2, 9. Hold on now. Okay. This is my X, this is my Y. I do not know what is the curve. Okay, so what we are doing in part A, we are basically finding the chord of AE. Then we are finding the gradient of chord BE, finding the chord of the gradient of chord CE, then finally finding the chord of the gradient of DE. So this question is actually testing you on your understanding of the concept of the differentiation from first principle. So recall that, okay, if you have a graph, so let me just use an example of a graph. Okay, so if I'm interested in the gradient at point X, or point X equals to 2, okay, then the gradient at X equals to 2, right, the gradient of this tangent, right, can be approximated to the gradient of the chord between the 2 points, and the nearer the 2 points are, the better the estimation. And when the other point on the chord is like almost the same as 2, has an x coordinate almost the same as 2, then it is equals to the exact gradient at x equals to 2. So if you take a look at it, the gradient, okay, that is closest to the gradient at x equals to 2 is probably DE, because DE, the point D, is closest to E compared to the other points. So you know that the gradient is closest to 2.1. Okay, but it's most likely not 2.1, okay, because the gradient of the chord is an estimation of the gradient of the tangent at E. Next, let's take a look at the pattern 4, 3, 2.5, 2.1. So very likely, right, the gradient at point E is maybe slightly lesser than 2.1. So in other words, right, we can say that f prime 2, which is the gradient at x equals to 2, or the gradient at point E, should be roughly 2. Okay? So that is the answer for this. So what this part tells you is, okay, for this part B, what you need to know is that the gradient of point E, okay, should be close to the gradient of the chord DE. Okay, but it will not be equal, it will be slightly different because D is still a distance away from E. It is only when the distance between D and E is approaching 0, then the gradient of DE is equal to gradient at E. Okay, but D is like 0.1 units away from E. So very likely, okay, the gradient is quite close to 2.1 but not 2.1. Then next we look at this pattern. Okay, so as the points get closer to point E, okay, the values get smaller, and from 2.5 to 2.1, very likely the gradient at E is slightly lesser than 2.1, so we give a value of 2. Okay. Next, let's move on to question 2. Question 2 is a question on functions. Okay, so in this question, you are asked to solve the equation f inverse x equals to g f x. Okay, so in order to do so, we first need to find what is f inverse x, and then we also need to find what is g f x. Then we equate them to find x. Okay, so to find f inverse x, we will let y equals to fx. Okay, so y equals to 3x plus 2. Next, we'll make x the subject. So we have x equals to y minus 2 over 3. So for f inverse x, okay, it is x minus 2 over 3. Alright? So now that I found f inverse x, the next step I need to do is to find g f x. So to find g f x, okay, it is basically g 3x plus 2, because fx is 3x plus 2. So I replace the fx here by 3x plus 2. Next, I will replace this 3x, the x in gx with 3x plus 2. So I'll get gfx being equals to 12x minus 4. Alright. Okay, so now that I have found f inverse x and gfx, I need to solve for f inverse x equals to gfx, right? So f inverse x is x minus 2 over 3. gfx is 12x minus 4. Okay, so do a cross multiplication. I have 36x minus 12 equals to x minus 2. So 35, so 36x minus x, I get 35x. I bring this over, so this becomes 12. 12 minus 2 is 10. So my x is 10 over 35, which is equals to 2 over 7. So therefore, the answer for this part, okay, is 2 over 7. Question 3 is an arithmetic progression question. Okay, so because it's an arithmetic series, okay, you can make use of these formulas in your formula booklet. Okay, so you have the terms formula. Okay, so for an arithmetic series, your nth term is a plus n minus 1d. The sum of the first n terms, you can take half n times first and nth term, or half n times 2a plus n minus 1d. So very likely we are going to make use of these formulas when we are doing the question. Okay, so now I know that I'll write out the formula. So I know that un equals to 2a plus n minus 1d, and then sum of first n term is half n, okay, 2a plus n minus 1d, or half n a plus l, where l is the nth term. Okay, now you're given an arithmetic progression has first term 7, so I know that a is 7. Okay, then you are given that the nth term is 84. So let me write first term a equals to 7, nth term, which is un, is equals to 7, because a is 7, plus n minus 1d. Okay, then the 3nth term, which is u 3n, is equals to 7 plus, just replace this n with 3n minus 1d, and I know that it is equals to 245. Okay, then this one is equals to 84. So effectively, I formed two equations, right? 7 plus n minus 1d equals to 84. Okay, and I also have another equation, 7 plus 3n minus 1d equals to 245. So I will simplify this, okay? So I know that, so I'll take 84 minus 7 first, I get 77. So I know that n minus 1d is 77. So d is actually equals to 77 over n minus 1. So I'll label this equation 1 because I have two unknowns, so I need to solve for them. Okay, so therefore I'll make use of simultaneous equations. Okay, so I'll do the same for this portion here. I will make d the subject, okay, and then later I'll equate them together. So I'll take 245 minus 7, which gives 238. So I know 3n minus 1 times d is equals to 238. So d is equals to 238 divided by 3n minus 1. Okay, next, 1 is equals to 2, right? Both are equals to d. So I'll take 77 over n minus 1 equals to 238 over 3n minus 1. Do a cross multiplication, I have 238n minus 238 equals to, okay, I'll take 77 times 3, which gives me 231n minus 77. So next, I'm going to put all the n together. So 238n minus 231n gives me 7n. Then I'll bring this over, so I have 238 minus 77. So I'm going to type everything into the calculator. Okay, so I'll get n equals to 23. So solving for n, I get n equals to 23. And the question only asked me to find the value of n. It did not ask me to find the value of d. Okay, so I'm done. So I found the value of n, which is 23, and that is the answer for question 3. Okay, next, let's move on to question 4. In question 4, you are given a curve with the equation y equals to fx, and you are given that f prime x is equals to 1 over square root x plus 6 over x squared, and that f3 is 1, so find fx. So if you are given f prime x, and you're asked to find what is fx, you will integrate. So integrate f prime x will give you fx. Okay, and remember when you do an integration, you have a plus c, so that is why they give you this to find the value of c. So let's first find what is fx. Okay, so fx is basically integration of f prime x with respect to dx. So let me write this in. So this one is 1 over square root x plus 6 plus 6x squared dx. Okay, I will change this to x plus 6 to the power of minus half. And I'll change this to 6x to the power of minus 2. Okay. So now to integrate this, I will take x plus 6 to the power of minus half. Then I add 1 to the power. Okay. So divided by the new power, which is minus half plus 1. Then multiply by the coefficient of x, which is 1. Okay. Next, to integrate 6x to the power of minus 2, I'll just copy 6. Then for x to the power of minus 2, I'll add 1 to the power. Okay, then divide by the new power. Okay, then plus a c. So simplifying this, I'll have x plus 6 to the power of half over half. Okay, then here I will have plus 6x to the power of minus 1 over negative 1 plus 6. Okay, let me further simplify this. Power half is simply square root. 1 over half is 2. So I have 2 square root of x plus 6. Okay, minus 6 over x plus c. Okay. Next, I need to find what is c because I'm given f3 equals to 1. So I know f3 is equals to 1. So I know when I sub in x equals to 3 here, I'll get a value of 1. So I have 2, 3 plus 6 minus 6 over 3 plus c equals to 1. Okay, so I'll simply just type this portion into the calculator. So I'll get 4 plus c equals to 1. So I know that c is negative 3. Once I know c is negative 3, I can write what fx is. So I found fx is equals to this. And I need to sub in 3 equals c equals to minus 3. So I have 2 square root x plus 6 minus 6 over x minus 3. And I have obtained the value of fx, which is what is required for this question here. Alright. Next, moving on to question 5a. So you are given the curve y equals to x squared plus 3x plus 4 is translated by 2, 0. That means you are translating it 2 units in the positive x direction. Find and simplify the equation of the translated curve. So if I were to let fx be equals to x squared plus 3x plus 4, a translation of 2 units in the x direction means we are drawing this. So we know that the translated curve is fx minus 2. So I'll replace all the x with x minus 2. Okay, they asked us to simplify, so I expand everything and then simplifying it. Okay, so x squared minus x. So the simplified equation of the translated curve is x squared minus x plus 2. Okay, so you can write translated curve is y equals to x squared minus x plus 2. Alright. Moving on to part B, the graph of y equals to fx is transformed to the graph of y equals to 3f minus x. So describe fully 2 single transformations which have been combined to give the resulting formation. Okay, so usually the rule of thumb is we do translation in x followed by scaling in x, then scaling in y, then translation in y. So if you look at this, okay, this minus x is basically like scaling in x. So we will first do this, the minus x, okay, then we'll do the 3. So this is a reflection of y equals to fx about the y-axis. So we will first reflect y equals to fx about the the y-axis. Okay. Then you do the tree, then scale the resulting graph. Three units. Okay, scale the resulting graph by a scale factor of 3, okay, in the y direction. Okay, so this is for transformation of graph. Moving on to question 6, find the coefficients of x squared and x cubed in the expansion of 2 minus x to the power of 6. So this is basically your binomial expansion, and you can find the binomial expansion equation in your formula booklet, so you do not need to memorize it. Okay, so it is here, binomial expansion, it is here. Okay, so we are interested in x square and x cube, so we are interested in these two here. Okay, so now I know that for 2 minus x to the power of 6, okay, so you know that for the coefficient of x square, okay, or let's find the term with x square first. Okay, so the term with x squared, we'll use this formula. So I know if I want square, it will be this, because here is x, right? So if I look at this, this is my a plus b, n. So my a is 2, my b is minus x, and my n is power 6, right, for the formula. So in order to get x squared, okay, I'll be looking at this term here. So it's n choose 2, a to the power of n minus 2, b squared. Okay. So n is 6, n choose 2, okay. Then a, which is 2, 2 to the power of 6 minus 2, which is 4, times b, which is negative x squared. Okay, so type it into your calculator. 6 choose 2 is 15. 2 to the power of times 2 to the power of 4, okay, then and so on. So I know that 6 choose 2 is 15, then I'm going to take times 2 to the power of 4, then here will be x squared. So I have 15 times 2 to the power of 4 gives me 240. So I know that the term with x squared is 240 x squared. So therefore coefficient of x squared is 240. Alright, next I'm going to do exactly the same thing for x cubed. So for x cubed, I'll make use of this here. So x cubed, I'll make use of this. So it's n choose 3, a to the power of n minus 3, b cubed. Okay, so let me write term with x cubed is equals to 6 choose 3, 2 to the power of 6 minus 3 minus x cubed. So 6 choose 3 is 20. Then I need to multiply by 2 cubed. Minus x cubed is essentially minus x cubed. Okay, so next I take 20 times 8 times negative 1 from the minus x cubed. I'll get minus 160 x cubed. So therefore, the coefficient of x cubed is equals to negative 160. All right. Okay, next let's move on to question B. Hence, find the coefficient of x cubed in the expansion of 3x plus 1 times 2 minus x to the power of 6. Okay, so you definitely need to make use of this. So we know that we have 3x plus 1 multiplied by 2 minus x to the power of 6. If I'm interested in the coefficient of x cubed, okay, and here I have 3x plus 1. So if I were to do an expansion, this 3x I need to multiply by a term with x squared to get x cubed, right? So I'll put in 240x squared here. So because I know that when I expand, I'll have something plus 240x squared minus 160x cubed and so on, right? Okay, so I know that to obtain an x cubed term, I'll take 3x times 240x squared. To obtain an x cubed term, I can also take 1 times minus 160x cubed. So I know that term with x cubed can be obtained by taking 3x times 240x squared plus 1 times negative 160x cubed. Okay? So I'll have 720x cubed minus 160x cubed, which gives me a value of 560x cubed. Okay, and the question asks for coefficient. So just write in the coefficient of x cubed, which is 560. Okay, so that is the answer for 6B. Right, next let's move on to question 7. Okay, question 7 is a trigo question. So you're asked to solve the equation 1, show that the equation 1 plus sine x tangent x equals to 5 cosine x can be expressed as this. So in other words, right, we need to make use of your trigo identities to manipulate this to get this equation here. So if you have to take a look at your formula booklet, okay, these are all the equations, and in paper 1, okay, you are tested on these two equations here. Okay, this is the first two lines. Okay, so very likely if you're doing trigo questions in paper 1 of your Cambridge International exam, just take a look at the first two lines of your identities for trigo, because that is what is tested in paper 1. It's only in paper 2 then you include all the other formulas. Okay, so in other words, very likely we will be making use of tangent theta equals to sine theta over cosine theta, or cosine squared theta plus sine squared theta equals to 1. Alright, so I'll write them out here. Okay, so I know that tangent x is equals to sine x over cosine x, right? I also have this formula, sine squared x plus cosine squared x is equals to 1. So these are the identities that are tested in paper 1. So very likely your question will make use of these two only. Okay, so coming to here, I have 1 plus sine x tangent x equals to 5 cosine x, and I want to change it to this, or in terms of cosine. So in other words, no more tangent, right? So I will change tangent to sine over cosine. Okay, so I'll first copy the question here. Okay, then I'll put tangent x is sine x over cosine x. Okay, so now I have 1 plus sine squared x over cosine x equals to 5 cosine x. Next, I do not have any denominator, so I'm going to multiply all terms by cosine x. So 1 times cosine x gives me cosine x. Sine squared x over cosine x times cosine x is sine squared x. Okay, then 5 cosine x times cosine x is 5 cosine squared x. Alright. Next, if you compare what we have here versus what we need to show, okay, we do not need sine squared. So we need to change it to cosine. So if you make use of this identity here, you know that sine squared x is equals to 1 minus cosine squared x. So I'm going to replace this sine squared x here by 1 minus cosine squared x. Okay, I'm going to bring this over. Okay, then I'm going to multiply the entire equation by -1. So I have cosine squared x minus cosine x minus 1 equals to 0, which is what I need to show. So therefore, I've shown. All right. All right. So now that I have done that, okay, the next thing I need to do is to go on to part B, and they ask us to solve the equation 1 plus sine x tangent x equals to 5 cosine x for x in between 0 and 180 degree. And they give us this for a reason, right? So they tell us that this can be written as this. It's going to be very tough to solve this. So we are going to solve this because everything is in terms of cosine. So we're basically going to solve quadratic equation, right? So we know that this 1 plus sine x tangent x equals to 5 cosine x can be written as 6 cosine squared x minus cosine x minus 1, right? So I'll simply just write this as 6 cosine squared x minus cosine x minus 1. So solving for this is the same as solving for this, because in part A we already showed that this can be expressed in the form of this. Alright, so now I'm going to solve for this. So this is like solving quadratic equations. So it is like your y is equals to cosine x. So you are solving 6y squared minus y minus 1 equals to 0, right? So when you solve this, you will have 3y and y minus 1 plus 1. Okay, minus 3y. Oops, sorry, it's 2 here. So minus 3y plus 2y. So this is how I factorize it. So I have 3 cosine x plus 1 times 2 cosine x minus 1 equals to 0. So this times this equals to 0. So either of them will be equals to 0, right? So either of them is equals to 0. So what I'll do is I will split it to 3 cosine x plus 1 equals to 0, or 2 cosine x minus 1 equals to 0. Okay? So now I'll find what is cosine x, which is equals to negative 1/3. So once I've written something in the form of trigo ratio angle equals to a value, okay, the next step is to find basic acute angle. So when you find basic acute angle, you ignore the negative sign. So it's cosine inverse 1/3. Okay. So it is, make sure that it is in degree mode because this is in degree, okay? So you get a basic acute angle of 70.528 degrees. Okay, I write maybe 3 decimal place because later on I need to round it off to 1 decimal place. Why I need to round it off to 1 decimal place? This is because if you have to look at your exam paper, it says that give non-exact numerical answers correct to 3 significant figures or 1 decimal place for angles in degree unless a different level of accuracy is specified in the question. So the question did not specify how many what to round it off to, and we did not get an exact value. Okay, so because it's an angle in degree, so we are rounding off to 1 decimal place. Finally, finally we're rounding off to 1 decimal place. All right, so coming back to here, okay, but because this is not the final answer, okay, so that is why I put 2 more decimal places. Okay, so next I need to find x now. So if I were to look at my quadrant A, S, T, C, okay, I know that cosine is negative. So cosine is in the second quadrant or the third quadrant. But if you look at the range of values of x is from 0 to 180 degrees. So I'm only asked to look at these 2 quadrants here. Okay, so I only need to look at the first and second quadrant. Okay, so first thing, from here, the range of values of x tells us we only need to look at the first and the second quadrant because it's from 0 to 180 degrees. Next, cosine is negative. So for cosine to be negative, it will be in the second quadrant. So we are just interested in the angle in the second quadrant. So it's 180 minus basic acute angle. Okay. Okay, so it is equals to 109.472 degrees. Now I'll round it off to one decimal place. So it's 109.5 degrees when rounded off to one decimal place. Similarly, I'll do the same for this. So I'll need to write cosine x is equals to half. Okay, so basic acute angle of x is equals to cosine inverse half, which is 60 degrees. Okay, then I know that for this question, x is in the first and second quadrant only, and because cosine x is equals to half, okay, to solve for cosine x equals to half, I will only be looking at the first quadrant. So the first quadrant, x is 60 degrees. So therefore, you have two answers for x. One of it is 60 degrees, the other is 109.5 degrees. So hence, x is equals to 60 degrees or 109.5 degrees, right? Okay, moving on to question 8. Question 8 is a differentiation question. So you are given y equals to 12 over 3 minus 2x. You are asked to find dy dx. So if y equals to 12 over 3 minus 2x, I can write it as 12 times 3 minus 2x to the power of minus 1. To find dy dx, I will first bring down the power. Okay, then power minus 1. Then I'll multiply by the differentiation of 3 minus 2x. So if I were to differentiate 3 minus 2x, I'll get minus 2. And don't forget your 12 here. So next, 12 times minus 1 times minus 2 is 24. So I have 24, 3 minus 2x to the power of minus 2. So I can write it as 24 over 3 minus 2x squared. Alright. Okay, now that I have done that, let's move on to the next part. A point moves along this curve. As the point passes through A, the x-coordinate is increasing at a rate of 0.15 units per second, and the y-coordinate is increasing at a rate of 0.4 units per second. Find the possible x-coordinates of A. So very likely we have more than one answer for B, okay, because I see the word x-coordinates. Okay, all right, so now I know that the x-coordinate is increasing at a rate of 0.15 units per second. That means dx dt is equals to 0.15 units per second. The y-coordinate is increasing at 0.4 units per second. So dy dt is equals to 0.4 units per second. Okay, and to link and there's a equation for chain rule, right? So in chain rule, so if I have x and y, okay, I can write dy dx times dx dt equals to dy dt. So I know that dy dt is 0.4. dy dx, I do not know what it is. I can find it. I want a numerical value. dx dt is 0.15. So therefore, dy dx is equals to 0.4 divided by 0.15, which gives me a value of 8 over 3. Now, I know that dy dx is equals to 8 over 3 at this point A. I also know that dy dx takes this formula here. So I will take dy dx, which is 24 over 3 minus 2x squared, is equals to 8 over 3. Do a cross multiplication. 8 times 3 minus 2x squared is equals to 24 times 3, which is 72. So 3 minus 2x squared is equals to 9. So if I were to square root both sides, then 3 minus 2x is equals to plus minus 3. So I have 3 minus 2x equals to 3, or 3 minus 2x equals to negative 3. Okay, so maybe let me write this in the next page. Okay, so why I did this portion is because I don't want to expand it. So I know that 9 can be easily square root. So I square root, if I square root here, I need a plus minus, okay? So I have 3 minus 2x equals to 3, or 3 minus 2x equals to negative 3. So to find 2x is equals to 0. X is equals to 0. Then here, let me find 6. 2x is equals to 6. X is equals to 3. So, x coordinates of A are 0 and 3. 0 or 3. Alright? Alright, now that we have done this question, let's move on to question 9. So question 9 is a question on circular measure. Okay, so let's go to the formula. Is there formulas for circular measure? Okay, so you have them here. Okay, so if you have arc length is r theta, where theta is in radians, area of sector of circle is half r square theta. So you can make use of these formulas for circular measure. Okay, so now coming back to this question here, you have a diagram here. It shows a circle with center A, radius r. Then diameter CAD and BAE are perpendicular to each other. A larger circle B, okay, has center B and passes through C and D. Okay, so you're asked to find the radius of the larger circle and show that it's equals to r root 2. So if you look at this, BC is the radius of the larger circle, right? Or I can also say that BD is also the radius of the larger circle. So maybe I want to use BC. Okay, so I know that radius of larger circle is equals to BC. So I want to find BC essentially. Next, I know that for the smaller circle, the radius is equals to r. So anything that goes from the center A to the diameter is the radius. So AC is the radius, AB is also the radius. And we know that BAC is a right angle triangle. So if I want to find BC, I can make use of Pythagoras theorem, right? So I know that BAC is a right angle triangle. So I can make use of Pythagoras theorem. BA square plus AC square equals to BC square. Okay, so AB is basically R, AC is also R. So BC is basically square root of 2R square, which is equals to square root 2R. So therefore, radius of larger circle is equals to 2 square root 2. Alright. Okay, next you're asked to find the area of the shaded region in terms of R. So I need to find this area here. Okay. So how would I find it? Okay, there are many ways to do this. So first, I will first erase this. So I need to find this area here. Okay, and to find this area, it is basically the area of this semicircle here, minus this area here, right? Agree? Okay. So what I'll do is I will first draw this back. Oops. Draw this in. Okay, and I do know that this angle here is 90 degree. Why is it so? If I have to look at this small circle here, the smaller circle here, this is the diameter. Okay, and so this is a semicircle. So angle in semicircle is equals to 90 degrees. So here is a 90 degree. Okay, so next I know that this is the radius of the larger circles, and this is also the radius of the larger circle, and this from part A I know that is r root 2. Okay, so do you agree that I can make use of the larger circle, find the area of this sector BCD, then I minus the area of this triangle BCD, I'll be able to find the area of segment CAD, this part that I shaded. Once I found this, I just need to take the area of this semicircle, the semicircle of the smaller circle, minus this portion here. Okay, so my aim is to find the area of this highlighted segment in yellow by taking the area of the sector minus the area of this triangle here. Okay, so let's find area of sector, okay, BCD. So I know that I'm going to use half r squared theta. Okay, and this r here is not r, in fact it is 2 root r root 2. Okay, so if I use to find, because this sector belongs to the larger circle, so the radius is r root 2, and this theta here is 90 degree. Okay, so because it is 90 degree is equals to pi over 2. Okay, so I have half times 2r squared times pi over 2. So it gives me a value of, so I'll get half pi r squared. Okay, so the area of this sector here, BCD, so this sector here, okay, is half pi r squared. Next, I want to find the area of triangle BCD. Because I have a right angle here, I know that I can use this as a base and this as my height. So half base times height. So it will be half base times height. Okay, so it is half times 2r squared, so it's equals to r squared, right? Yes, r squared. Okay, so next I want to find the shaded in yellow, the area of the segment. Segment is this portion shaded in yellow. So let me write this. Area of segment, this segment is called CADX. Let me call it CADX. CADX, then CX marked in figure. So it will be equals to the area of the sector, which is half pi r squared minus r squared. So it is half pi minus 1 r squared, right? Okay, so I have found this yellow portion. Then to find the area of the shaded portion is equals to area of the semicircle of the smaller circle minus this yellow portion, which we have found is half pi minus 1 r squared. So area of semicircle CADE is equals to half times pi r squared, because the radius of the smaller circle is r. So it's pi r squared times half, because this is half of a circle. Okay, finally, to find shaded area is equals to the area of the semicircle, half pi r squared minus this. Okay, so basically you have half pi r squared minus half pi r squared plus plus r squared. So therefore the shaded area is equals to r squared. So the answer for this, the area of this shaded region, is equals to r squared. Okay, next let's move on to question 10. So in question 10, okay, is basically testing us on coordinates geometry for circles. So you're given the equation of a circle, x squared plus y squared plus 4x minus 2y minus 20 equals to 0. So recall that if you have a formula for your circle, x squared plus y squared plus 2fx plus 2gy plus c equals to 0, then your center, okay, occurs at minus f minus g, right? Okay, so they ask you to state the coordinates of c, which is the center. So I know that my 2f is 4, my 2g is minus 2. So in other words, my f is 2, okay, and therefore my minus f is minus 2. So c is minus 2, because they ask you to state, you can just write it in. So I know that my 2f is 4, f minus f is minus 2. My 2g is equals to minus 2, my g is equals to minus 1, so my minus g is 1. Okay, so my center of the circle is equals to minus 2, 1. Alright. Okay, next, it is given that the midpoint D of AB has coordinates 1, half, 1.5, and 1.5. Find the equation of AB, giving your answers in the form y equals mx plus c. So you know the circle passes through 2 points A and B. Okay. So now we know that, okay, it passes through A and B. Okay, and so what I'll do is, I know that this is, maybe this is A. Okay, I know here is minus 2, comma 1. Okay, next, I know that I have points A and B. I do not know where A and B are. So this A, this is B, for instance. And I know that it has a midpoint, which is at 1.5 and 1.5. Alright? So you need to find the equation of AB, giving your answer in the form y equals to mx plus c. Okay? So we know that this is AB, this is the center C, and this is the midpoint 1.5, 1.5. Okay? And what do we know? We know that C to the midpoint is perpendicular to AB. Okay? So we do not know A and B, right? But we know that, so let me draw bigger, maybe it's easier. So this is point A, this is point B. I have no idea where A and B is because it is not given, but I do know that this is its midpoint, D, and D occurs at 1.5, comma 1.5. So from south, and this is point C, which is the center. And we know that from C to D, it is perpendicular to AB. Okay. Next, we know that D will also lie on the line AB. So in other words, right, we can make use of this concept to find the equation of the line AB. So firstly, I know the point C, which is minus 2, 1. So I can find the gradient of CD. Next, I know CD is perpendicular to AB, so I know the gradient of AB. Now I know gradient of AB. To find equation of the line, I just need another point. So I know that apart from A and B that lies on this line, AB, D also lies on the line. So I can make use of this line, this point D, to find the equation of AB. All right. So let's say gradient of CD is equals to, okay, let me put in the points of D first. Okay, so I can find the gradient. Okay, so it's equals to 1 over 7. So I know that CD is perpendicular to AB. So therefore, the multiplication of their gradient will give -1. So gradient of AB will be equals to -1 over 1 over 7, which will give me -7. Once I found the gradient of AB, you can find equation of line AB, because I know D is a point that lies on the line AB. Okay, so remember that if you have a circle, okay, and you have 2 points on the circumference, the midpoint and the center will be perpendicular to AB. Okay, this is the circle properties that you need to make use of in this question. Okay, coming back to this, we know that D lies on AB, so D is a point on the line AB, right? So equation of AB, we'll use this formula, y minus y1, so y1 I'll use 1.5, equals to m, which is -7, x minus x1. Okay, next let me simplify this. So 1 minus 1.5 equals to -7 plus 7 times 1.5, which is 10.5. Okay, then I'll bring this minus 1.5 over. So I have y equals to -7x plus 12. So the equation of the straight line is y equals to -x plus 12. Okay, next you're asked find by calculation the x coordinates of A and B. So I know that this is the equation of the curve. This is the equation of this line AB. So how do you find the points A and B? So if you look closely, point A and B are the points of intersection between the line AB and the circle. And whenever you're finding point of intersection, you solve simultaneous equation. So I'll label this equation x squared plus y squared, then what is it? Plus 4x minus 2x minus 20 plus 4x minus 2y minus 20 equals to 0 as equation 1. Okay, and in equation 2, I have y equals to -7x plus 12. So I know that A and B is the point of intersection between this circle and this line AB, right? From this diagram here, I know AB is the point of intersection between this line AB and this circle. So to find point of intersection, you solve simultaneous equation. So y equals to -7x plus 12 is already returned in terms of y. So y is the subject already. So I can substitute equation 2 into equation 1. Okay, so I have x squared plus -7x plus 12 squared plus 4x minus 2 times -7x plus 12 minus 20 equals to 0. So let me expand everything. I have x squared plus 49x squared, okay, minus 168x plus 144 plus 4x plus 14x minus 24 minus 20 equals to 0. So let me put all the x squared terms together. I have 50x squared. Let me put all the x terms together. So I'll take -168 plus 14 plus 4, which gives me negative 150x. Then finally, let me put all the terms, all the constant terms together. Let me circle them out. So it'll be 144 minus 24 minus 20, which gives me a value of 100. Next, I factorize out 50 of x squared minus 3x plus 2 equals to 0. So effectively, I'm solving x squared minus 3x plus 2 equals to 0. This will give x minus 2, x minus 1 equals to 0. So x equals to 2 or x equals to 1. Then I sub into 1. I get y equals to minus 7 times 2 plus 12. So it's negative 2. Then sub x equals to 1 into 1. I'll have y equals to minus 7 times 1 plus 12, which will give me 5. Okay. So now that I'm done with this, I have found the coordinates of A and B. Okay. So, they only want coordinates of A and B. So in fact, I did a bit more. So I do not need this step because they only want x coordinates of A and B. So the answer is 1 and 2. Okay. So x coordinates of A and B are 2, x equals to 2 or x equals to 1. All right. Moving on to question 11. So you have the function f is defined by this, fx equals to x squared plus ax plus b, where a and b are constant. It is given that a is 6 and b is equals to minus 8, and you're asked to find the range of f. So this, I will write fx equals to x squared plus 6x minus 8. And to find the range of a quadratic function, we will need to complete the square. So I'll get x plus 3 squared minus 8 minus this value here, which is 3 squared, right? Okay. So I have x plus 3 squared minus 17. Okay. So next, now that I've completed the square, I'll be able to find the minimum point. So because the coefficient of x squared is positive, because it's 1, so I know that the graph looks like this. So the minimum point occurs at minus 3, minus 17. So I know that range of f must be greater than or equals to minus 17, because this is the smallest value that fx can take. Alright, let's move on to part B. So it is given that a is equals to 5. So now your fx, which is equals to x squared plus ax plus b, your a is equals to 5. So we have fx equals to x squared plus 5x plus b. Okay, and that the roots of the equations when fx is equals to 0 are k and minus 2k, where k is a constant. You're asked to find the values of b and k. So we know that since the roots, okay, so when x squared plus 5x plus b, or your fx is equals to 0, we know that you have x equals to k and x equals to minus 2k as the solution. So one step before, you have something like this. Okay, so what we are going to do is, I know that x squared plus 5x plus b is equals to 0. Okay, so when this is equals to 0, I know that x equals to k and minus 2k are the roots. Hence, I know that I can write this in the form x plus k, x minus k. Okay, so that I have the root k. And x plus 2k equals to 0. And this must be equals to this, right? So x minus k, x plus 2k is equals to x squared plus 5x plus b. Okay, so I'm going to expand this portion here. So I have x squared plus 2kx minus kx minus 2k squared equals to x squared plus 5x plus b. So I have x squared plus kx minus 2k squared equals to x squared plus 5x plus b. So if I compare the coefficient of x, I know that k is equals to 5. And b is equals to minus 2k squared, which is equals to minus 2 times 5 squared, which is equals to minus 50. So k is 5 and b is minus 50. Okay, moving on to part C, show that if the equation fx plus a equals to a has no real roots, then a squared is lesser than 4b minus a. So if we see no real roots, we know that discriminant is lesser than 0. So we need to make use of this concept to show this. So let's first find out what is fx plus a. So I know that fx is x squared plus 5x plus b. So fx is equals to x squared plus ax plus b. So fx is equals to x squared plus ax plus b. So if I have fx plus a, I will replace all the x with x plus a. Okay, and I know that this is equals to a. So I'm going to write it this way. Next, I'm going to expand and simplify. Okay, so now I'm going to put all the terms with x together. So I have 2ax plus ax. It will give me 3ax. Next, a square. So a square plus a square, 2a square. Okay, plus b minus a. Next, I know since fx plus a equals to a, they use if, so I'm going to use the if instead. If this has no real roots, then my discriminant is lesser than 0. So I'll apply discriminant. So the coefficient of x is 3a. So this squared minus 4 times 1 times 3a, okay, plus 2a squared plus b minus a. This is the constant term. Okay, next I will expand and simplify to show that a squared is lesser than 4 times b minus a. So 3a squared is 9a squared. Okay, then I have 8a minus 8a squared minus 4b plus 4a is lesser than 0. So 9a squared minus 8a squared is a squared. Then I move these to the other side because I need to prove this. Okay. Okay, then I will factorize this to show that a squared is lesser than 4 times b minus a. Okay. So a squared is lesser than 4 times b minus 8, and I've shown what is required. Alright, next let's move on to question 12. This is a differentiation and integration question. So the diagram shows the curve with this equation. The minimum point on the curve has a coordinates a0, okay, and the x-coordinate of the maximum point is b. So where a and b are constant, state the value of a. So if you want to state, you can just write the answer. So if you look at this, at point a, y is equals to 0. So when y is 0, x minus 2 squared is equals to 0. So x equals to 2 or 0 or 2. But we know that a is not 0 because 0 is here. So a is equals to 2. Okay, or if you know directly, you can just write a equals to 2 because the question only asks you to state. So you can just write the answer. Just write a equals to 2 if you can see it directly. Next, you are asked to calculate the value of b. So b is the maximum point of the curve. So at minimum as well as at maximum point, we know that your dy dx is equals to 0. So what we need to do is to find dy dx, equate it to 0 and find the x value. So the one that is not equals to 2 will be the value of b. Alright? Okay, because at both x equals to a and x equals to b, okay, you have dy dx equals to 0 because minimum and maximum point, the gradient is equals to 0. Okay, so now we have y equals to x minus 2 squared. So before you differentiate, let's expand it. Okay, so we have x cubed minus 2x squared plus 4x. Next, let's find dy dx. So it is equals to 3x squared minus 4x plus 4. Okay, so now I want to calculate b. So when dy dx is equals to 0, okay, you have 3x squared minus 4x plus 4 equals to 0. Factorize it, you will get x minus 2, 3x minus 2 equals to 0. So you have x equals to 2 or x is equals to 2/3. So we know that b is in between 0 and 2/3. So b is equals to 2/3. Sorry, b is equals to 0 and 2, right? A, the x coordinate of a is 2. So therefore you won't take 2 for b. It will be 2/3. Next, find the area of the shaded region. So the shaded region is basically the area between the curve and the x-axis from x equals to 0 to x equals to 2. So to find this area, we will integrate y from 0 to 2. Okay. So area is equals to integrate from 0 to 2 y dx. Okay. And y is x cubed minus 2x squared plus 4x. So remember, there's no product rule for your integration, so you have to expand it. Okay. Next, let's integrate x cubed. You get x to the power of 4 over 4. Okay, minus 2x squared over 2 plus 4x squared over wait, did I calculate 2x 3 3. Okay, sorry, this is square. Then I need to sub in 0 and 2. So if I sub in x equals to 2, I have 2 to the power of 4 minus 4 over 2, 2 cubed over 3 minus 4, 2 square over 2. Then if I sub in 0 into this, I get 0. Okay, type everything into the calculator, you'll get 4 over 3 units square. Next part D, the gradient dy dx of the curve has a minimum value m. Calculate the value of m. So let's take a look at the gradient. So dy dx is equals to 3x squared minus 4x plus 4. So let's first write this down. And we know that this is a quadratic function. To find the minimum value of a quadratic function, we need to complete the square. So let's complete the square. Okay, so basically you just take, if you have ax squared plus bx plus c, to complete the square, you bring out the a, then here will be b over 2a square. Oops, I forgot my 2. Okay, then this portion here will be c minus b square over 4a, or it is basically b square over 4a square times a in minus of it. Okay, so you can just remember the formula is much easier anyway. Just remember this formula. So you'll have this. Okay, then 4 minus 3 times 4 over 3 squared will give me a value of minus 4 over 3. So I know that the minimum value, okay, of this quadratic function is negative 4 over 3. So m is minus 4 over 3. All right.